Today's lesson is all on the unit circle. A unit circle is a circle that has a radius of 1 unit. So the radius from the center of the circle starts at the center of the circle at 0, 0, and goes all the way out. In this case, we're going to think about our coordinate grid, goes out to 1, 0, has a radius of 1. An angle of 1 radian is an angle at the center of the circle. Okay, so here's that angle at the center of the circle, which is measured in a counterclockwise direction that subtends an arc length. Okay, this is that arc length that is created that is equal to 1 radius as well. So if you have 1 radius here, this arc length is also 1 radius. So if we call this angle theta, okay, we'll call it theta because we don't know exactly what degrees it is. We can also identify the trig ratios here. If we were to create a right angle and bring this point down to the x-axis, bring a line down to the x-axis to create that 90-degree angle, we can say that the sine of theta, okay, is here because we have the opposite over the hypotenuse, because we're going to remember that this radius is also 1. So this is the y, because if you notice, this is the sine is taking the distance of the y-axis because it goes up and down, and the distance going across here, right, on the bottom portion would be the cosine of theta because it is the adjacent over the hypotenuse. So you still got to remember your trig ratios. If we remember SOHCAHTOA from yesterday, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we have our x value here, and we also have our y value right there. So the the sine of theta is y over 1, and the cosine of theta would be x over 1, which would just be x, right? And the sine of theta, which is y over 1, would just be y. Another thing to think about is if we have a point on our unit circle, okay, so say this point here, we bring it towards our center of our circle, and we have to remember this is known as our terminal side. Terminal, because it's where it stops, I'm sorry. It starts here, we go around here, and we're going straight up, and we want to know how many angle degrees we have here at this point, starting from our 1, 0, and if we were to open up the circle and start all the way around. Now we know that this is 0 degrees on a circle, go all the way up to where we have 0, 1, this is 90 degrees. And if we keep on going on our unit circle, we have a full line is 180 degrees. Keep on going, we have 270 degrees. And then all the way back through, if we make a full complete rotation, we're at 360 degrees for a circle. So if we wanted to approximate what we have here, we could say that this is approximately about 20 degrees. So if we added up 90 and 20, we'd get approximately 110 degrees would be at this point. We can call this point A, point B, whatever we wanted to. And we have to remember we're always going for positive degrees. We are going counterclockwise. And for negative degrees, we are going clockwise. Okay, it's always the backwards way of a clock. Okay, I'm going to stop this video here, and we'll pick up the next video and discuss our model problem and our check for understanding.